Welcome to this video on electrical power and energy transfer. We will cover how appliances transfer energy, how we measure power, and how electricity bills are calculated for GCSE Physics. In this video, we will explore what power is, the key units like volts and amperes, how energy relates to time, how electricity bills work, and essential exam tips. Electrical appliances are designed to transfer energy into useful forms, like heat, sound, or light. Remember, in physics, energy is always transferred and never created or destroyed. Electrical power is the rate of energy transfer. A higher power rating means a device converts energy more quickly. For example, a 2,000-watt kettle boils water faster than a 1,000-watt one. Power is measured in watts, where 1 watt equals 1 joule per second. You will also encounter kilowatts and megawatts for larger power ratings. To succeed in physics exams, be confident with these standard units: volts for voltage, amperes for current, seconds for time, and joules for energy. The relationship between power, voltage, and current is given by the equation: power equals voltage times current. This is a fundamental concept in many exam questions. Let's apply the power equation. For a hairdryer on a 230-volt supply drawing 10 amperes, we multiply 230 by 10 to get a power of 2,300 watts. Higher current leads to more heating, which can be dangerous. Household circuits use fuses and breakers to prevent wires from overheating, as heating power increases with the square of the current. Total energy transferred depends on power and time. Use the equation: energy equals power times time. Always ensure time is in seconds for these calculations. When calculating energy, always convert time from minutes to seconds. For a 1,500-watt iron used for 10 minutes, convert to 600 seconds, then multiply to get 900,000 joules. Because joules are such a small unit, energy companies bill us using kilowatt-hours instead. This is the unit you see on your home electricity bill. 1 kilowatt-hour is the energy used by a 1 kilowatt appliance running for 1 hour. That is equivalent to 3.6 million joules and costs typically 25 to 30 pence per unit. To calculate energy in kilowatt-hours, multiply power in kilowatts by time in hours. For a 2-kilowatt kettle used for half an hour, the energy consumed is 1 kilowatt-hour. Familiarize yourself with these common appliance power ratings. Knowing these values helps you estimate real-world energy usage and confidently answer related exam questions. To calculate the cost of electricity, multiply the energy used in kilowatt-hours by the price per unit. For example, if a washing machine uses 2 kilowatt-hours and electricity costs 28 pence per unit, the cost is 56 pence. You can reduce your electricity bill by using lower power appliances or reducing the time they are used. For example, replacing a 100-watt bulb with a 10-watt LED saves significant energy over a year. Time is just as important as power. You can save energy by turning off appliances at the wall to avoid quote-unquote vampire energy drain, taking shorter showers, or using eco settings on your appliances. Look for energy efficiency ratings when buying appliances. Higher rated appliances transfer more energy into useful outputs like light or motion, and waste less as thermal energy, lowering your cost over time. Energy efficiency is about minimizing waste. An old incandescent bulb wastes 95% of its energy as heat, while a modern LED bulb converts up to 90% into useful light. Always remember that energy transfer requires both power and time. You cannot calculate total energy consumption without both of these values. Just like filling a bath depends on the tap's flow rate and how long it's left on. Here is a summary of the core equations you need for your exams. Master these to calculate power from voltage and current, or energy using either standard SI units or kilowatt-hours. Be prepared to rearrange these formulas. Whether you need to find power, voltage, current, energy, or time, practice using the triangle method or algebraic manipulation to solve your exam questions. Here is a critical exam tip: never mix up your units. Using the wrong unit, like joules instead of kilowatt-hours in a cost question, will result in lost marks, even if your arithmetic is perfect. Know the difference. Use joules for physics equations where time is in seconds, and use kilowatt-hours for billing and costs. If a question mentions an electricity bill or meter, you must use kilowatt-hours. If you need to convert between them, remember that 1 kilowatt-hour is equal to 3.6 million joules. Multiply by this number to convert from kilowatt-hours to joules, or divide to go the other way. Let's practice. For a toaster with 230 volts and 4 amperes, the power is 920 watts. Using it for 5 minutes, which is 300 seconds, gives an energy transfer of 276,000 joules. In another example, a 3-kilowatt oven used for 2 hours consumes 6 kilowatt-hours of energy. At 30 pence per unit, This costs 180 pence, or £1 and 80 pence per day. Watch out for common errors. If a student claims a 2,000 watt shower uses 2,000 joules every hour, they are wrong. They must convert hours to seconds and realize the energy value is much higher. Final advice? Watch your units. Convert time to seconds for joules. Use kilowatts for kilowatt-hours, and always differentiate between power and total energy. Good luck with your studies. Let's take a deeper look at the heating effect of current. When current flows through a resistor, energy is transferred to thermal energy. This is defined by the power equation, P equals I squared times R. Safety devices like fuses and circuit breakers protect circuits. They work by breaking the circuit if the current becomes dangerously high, preventing damage or overheating, based on the heating effect of the current. This diagram summarizes energy transfer. Energy enters from the supply, and power dictates the rate of transfer. Ultimately, useful work is performed, though some energy is always lost as waste heat. In the real world, smart meters provide real-time updates on your energy consumption in kilowatt-hours. They help households monitor their usage and make smarter decisions about when and how to use appliances. Comparing costs between efficient and inefficient appliances reveals why efficiency matters. Over the lifespan of an appliance, the energy savings from efficient models usually far outweigh the initial purchase cost. Keep this quick reference card for standard units handy. You will need to know these for your exam. Watts for power, volts for voltage, amperes for current, joules for energy, and seconds for time. These 4 equations are vital for your exam. Practice using them in both directions, whether you are calculating power from current or determining the cost of your electricity based on total energy used. Before submitting your exam, run through this checklist. Ensure you have the correct equations. Your units are consistent, such as converting time to seconds or hours, and your final answers make physical sense. Remember these key takeaways. Power is the rate of energy transfer. Know your formulas inside and out. Use kilowatt-hours for billing, and prioritize efficiency to save on your energy costs. You're prepared for the exam. Just remember to revise your equations, practice past papers, and double-check your units. You've got this. Good luck!